And now let's welcome on stage Viktor. He will be talking about XPath.
Hi, everyone. As Anna was saying, my name is Viktor. We're talking a bit of XPath, and we talk about. I'm sure most of you heard a little bit about it. So, what is XPath? XPath is the XML path language. It's a way of selecting paths out of XML documents. It's standardized by WGC, so we have an XPath standard. And it's used in some of the sort of XML domain stuff, like the XSLT transformation library. In Yang, and therefore in the stuff we care about, we're standardized on XPath 1.0. There are more modern standards, but everything we're going to talk about is focused on XPath 1.0. That's what IETF has settled on for all the Yang standards that exist. And why is XPath relevant in NSO? Well, part of it is because of that standardization with IETF, but we have extensions, right? So we can think of the NSO CDB database as one big XML document. Of course, that's not how it's actually stored, but a lot of the access into the database behaves as if it was an XML document. This is true for all the XPath stuff we're doing. All of the XPath and NSO can work on the database as if the database was an XML document. So there are a number of things that we get out of the Yang standard. Things like must expressions, when expressions, and we have some things like leaves refs and identity refs. There are weaker versions of XPath. There are still XPath, but you cannot use all the features. Some would say you can use barely any of the features. But we also have things that come out of NSO itself. If you were here a moment ago, you heard about nano services that use XPath quite a lot. We have templates, we have kickers, right? So you can use XPath in pretty much all the phases of NSO development. And during this example, we'll use a very small Yang model, what I call the world model. So the world contains people. Every person has a name, an age, and a hairstyle, either long or short. And the payload that I'm looking at something like this, right? You have the world with a person called Charlie, who's 11 years old and has long hair. The name here is the key, of course. So XPath is a path into the database. It looks a lot like a file system path with slashes and names. And sometimes prefixes, as Martin was just talking about. There are cases where you're allowed to have multiple names that are similar from different Yang modules. But each Yang module is supposed to have a unique prefix. And that prefix means that the path is always unique within your database, as in this example. But what makes it very different from a file system path is the predicates. So in this case, right, you have the name has to be Charlie. Within square brackets, you have these sequences of constraints on the path. And the result of an XPath evaluation is always either a node or a node set. I don't think people think about this enough, that you essentially have two different data types. You have collections and you have basic elements. Unfortunately, in XPath, there is no way of converting between these, or no good way of converting between these. So you have to keep in mind if what you're getting could be multiple hits or a single hit, because it makes a difference what happens after that. And every XPath expression is executed in a context. There's always somewhere this XPath is running. And if you don't have any other context, you have sort of the global context. And why does context matter? Because paths can be either relative or absolute. And once again, this is very similar to a file system path. You can use dot for the current node and dot dot for one step up, just as in a file system. And the context is what determines how relative paths are evaluated. Absolute paths are always evaluated with respect to the global context, of course. But if you do not start your path with a slash, you get a relative path. And in this example, we have, assume that the context is the long hair of Charlie. Then dot dot is the Charlie record itself. And dot dot slash age is the age of the current person. And there is a special function called current, which gives you the original context of your XPath. Because some XPath queries do quite a lot of searching the database. And what current lets you do is it lets you look at where you started your search. And I'll give an example a little bit later, because current might be the most common feature that's the hardest to understand. So we have something called XPath expressions, and they are sort of simple things, right? You can do strings, you can do numbers, you can do paths. You have some basic operators. These are all the operators you're used to, with one important caveat. You do not use slash for division. XPath is already uses slashes for enough stuff. So instead you use div and mod for division and modal operators. And then you have functions. There are a lot of XPath functions, doing things like counting the number of elements in the node set, checking if a string starts with a certain letter, etc. Now, there are a lot of functions. Most of them turn up in the W3C standard specification. In this slide deck, I have an appendix with examples of all the functions. And towards the end, there is a link to a GitLab repo that has example functions for all of the XPath functions supported. You can look at that after this presentation. We don't have time to go through them one by one. And we mentioned the predicates. A predicate is any Boolean expression running on a path, letting you filter out the path that you're interested in or not. So this test doesn't have to make sense, right? Of course, you don't normally want to use a path that doesn't make sense. But what this means is that normally, and this is maybe 95% of the predicates you want, is filtering on a key value. And this is very efficient NSO, that you select an element from a list using the key, such as this comparison with Charlie. But you can do anything you want. You can find anyone who's older than 18, anyone with a name that starts with a C. And note here that both age and name here are relative paths. They're evaluated in the list. So if you don't give any predicate, you will hit every element in the list. And then you can use these relative filters to filter out subsets of the list. And as I said, a predicate doesn't have to make sense, right? You're allowed to search for every person where 1 is greater than 2. I mean, it's never going to be true. 0 people like that, but you can do anything like that. And you can have multiple filters. You can either just change the predicates and say name starts with C and age is greater than 18. Or you can use the Boolean relational operators and combination operator, use and or in your query to combine filters together to more complex filters. And as Martin was saying, right, you can use the pipe display command. There are two relevance here, right? There's pipe display XML that actually shows you the XML document that's represented by NSO. And there is pipe display XPath that gives you this base XPath for finding a particular element in the database. And what it does is it will always show you the key in the predicate. And you can troubleshoot XPath in NSO using the XPath trace. You can turn it on globally. Or you can use pipe debug XPath when you call a function or commit to get a fairly detailed evaluation. And in DevTools, and we'll get back to that in the demo, you can turn on DevTools true and get access to the XPath command in NSO. It lets you evaluate XPath expressions live. So that's sort of where we're going. And you can end up putting this all together into fairly complex XPath. So let's give an example. Let's say I want the sum of the ages of every person above the average age. So we can start by finding the average age. That turns out to be pretty easy. We have a function called average, and I just give the unfiltered path. So this is every person in the world and their age. In this case, I have the ages 11, 51, 21, 41, and the average is 31. I can then start filtering out all the people whose age is above average. And I do the same thing. I do a filter where age, and this is then that relative path, has to be greater than that first average expression. And I find out that the two people above average age is Chuck and Viktor. And I can then add one more level and just sum up those ages. And I find out that some of these ages is 92. And that's sort of how using the XPath eval command, sort of gradually building up the XPath expressions. You can call XPath from code. So you can use the query API. And the query API is really cool. It lets you do sort of essentially SQL-like queries towards NSO using XPath. And it's available over RESTconf and over the programmatic APIs. You have to be a bit careful for a lot of the stuff you do with XPath because very, very big queries can become pretty inefficient. But it's probably the most efficient way of querying the NSO database. And then you have both XPath eval and XPath eval expression. We'll talk about it in a moment and let you run XPath from your code. If you run Python, Magic is really convenient, but turns out that for large databases and large queries, it's pretty slow and uses quite a lot of memory. And these are very efficient ways of finding out some data. But as I said, the most efficient query filters based on keys. Try to do filtering early. Let's try and get the queries out. And query on keys as much as you can to get that speed up. So let's do a demo. Unlike the previous cowards, I'm going to do a live demo. I'm sure nothing can ever go wrong. We're about to find out. So, as I said, we have to turn on DevTools like this. DevTools true. And we have a little bit of data in world. And we'll get back to the nice people in a moment. It's a bit of an extra trick. So we have a few people. We can go into config mode and use this XPath eval trick. And the first thing we can do is we can try and find out what kind of people are in the world. Who knew that the program I can't spell? So I evaluate this, and this gives me all the elements in the world. And I can start adding things to this, right? There is, for instance, this star operator that gives me every child node in a particular position, like this. That lets me look at all the people, all the properties. And this is exactly the same information that I got out of show, but using sort of an operator. And I can get, once again, all the ages and stuff like that. And I can start doing the filtering, of course, right? I can do everyone who is older than 15. And I can get everyone who's younger than 15. And start doing this kind of live filtering to see what result I will be getting. So before I start putting into my code, into my templates, I can do these sort of soft interactive runs. So we talk about context and about current, and I want to dig into that a little bit. So XPath here has a number of different things you can do. And we can set a context. So let's set Maria as the context, like this. So if I evaluate something in the context of Maria, then dot becomes that node. So let's say that I want to find everyone who's older than Maria. So what I'll do, I'll evaluate in that context world, people, age, greater than, current age. What am I doing wrong? Oh, expert. That's great. Let's see. I can do people, age. Right. So, of course, this is where I need both the dot and current, right? Because dot, as I move through like this, dot age will always be the age of the person I'm inspecting, right? People here loops through all the people. And as I go through this evaluation, the dot will always move context into that person I'm evaluating. So I can do this, and that age will always be relative to the current node I'm in my search, but current then turns out to be Maria. Maria is Maria is where I started out this journey. So that's what I can use context for. And I can do things like check must expressions and stuff like that in this situation to sort of help, explore what a must expression would do in a certain context. But I want to talk to you about nice people, right? So in addition to people, I have nice people. And nice people here have an index and they have a leaf ref into a normal person. So I can do this. And find out I have two nice people. And I can look at one of them. Let's say like this. So this is two people, right, with a number and a name. And then we have a magic XPath function called deref. So this is a leaf ref into the original list of people. So when I do deref here, you can see I get an entirely new node. I don't just get a value of the name anymore. What happens when I run deref is that it moves me over to where the leaf ref points. So when you have a leaf ref in your Yang model, you can use this to sort of teleport over to where it refers to. And then I can get, say, the age. I mean name, of course. I can do this and get the age of Maria, even though that's not present in the nice people list. So that's pretty cool. And then the other thing we can do look at the XPath trace. So let's assume I try to add a new person. I'll add a new person called Sorrow, who is he's old by now, 160 maybe, 170. I do commit dry run pipe debug XPath. And it turns out that I have a must expression that says that I do not allow names that start with a Z. And this is this expression, right? Not starts with name Z. And I get an error when I try to commit this because I have this must expression validated. And I can use this to get this trace of what's going on when I commit. The final thing I wanted to show was that you can also use this from the Python API. And if you haven't used NSS PyCLI, so this is, you can pip install this. It's an IPython mod that lets you run Python code against NSO. It's very convenient. And what you can do, one of the things you do is you get a trans object here. It's a transaction running against NSO. So what you can do, you can use trans.xpath like this. So I can evaluate an XPath, say I want to do world people as usual. And then this calls a callback function for every hit in the XPath. So this is for when you get a node set result and want to deal with each element. And then you just do, you can get lambda function, lambda, path value, print path value. And then I get to do a debug function if I want to have traces and stuff. And then I give a context like this. In this case, the context doesn't really matter. And this prints every person. So, say I care about the ages of all the people. I get a number of different paths and the values, and I can do anything I want with these. Of course, printing is very primitive. I might want to add them to a database or a hash table, or I might want to take some further action, right? And this lets me evaluate every element in a node set. But what about if I care about something else, right? Let's say I want to evaluate the sum of all the ages of people in the world. Well, of course, this will still work, except sum doesn't give me an XPath node set. It gives me a value. So what I do, I move instead to XPath eval expression that results in a string rather than a callback, and then I can do some world people age. I don't have the callback function anymore. I do have a trace function, and I do have a root function. Like this, and then let me sum all the people in the world. And this is a way from Python to do sort of things that analyze elements in the database, and the results in a string. You can use XPath eval like this. So it's really, really neat, and lets you sort of do fairly advanced calculations and analysis from code. Because when you use the Python API, one of the things you have to watch is the number of round trips between a Python VM and NSO system. And offloading onto XPath instead of doing it yourself through Magic really helps our performance. So the only problem with doing a live demo is I cannot spell live, but other than that, it went really well. So let's sum this up for a moment. XPath is really cool. Actually, this is just being a little bit recorded. XPath is pretty horrible. But on the plus side, every query language is horrible. These days, JQ has become very, very popular. And if you look at the workflow sessions, we'll talk about JQ. And that's also very horrible. So, you know, better to stick and learn something than to sort of hop around. There's lots to learn. Performance is important. There is a lot of general XPath material on the internet if you want to learn more. There are some more advanced concepts, in particular something called access that I have not covered at all. It's very rarely relevant with NSO, but there are a few cases where the access matter. You can learn about those on the internet. When this is published, there will be backup slides published with all the XPath functions. This GitLab repo has all of the examples. It has an example Python file which runs through all the different functions available. It has a benchmarking tool, a few cool things like that. And if you care about XPath uses in templates, here's an old YouTube recording of a previous dev days. We can learn all about how to write advanced templates leveraging XPath. So that was all I had to say. Thank you very much for listening to me for 20 minutes, and I hope that you have a good conference. I think we have time for a question or two. If everyone just wants to go have coffee, that's fine. And I'll see you guys around. Thank you very much.